Let's look at the solution to this problem in Excel, which is very similar to what you're going to be asked to do for classwork. So we have data we've extracted from the USGS's website for the White River near Fayetteville, Arkansas. We have a full year's worth of data. You can see it starts on January 1st and goes all the way down, way at the bottom down here. Where are we? Yeah, to 12/31, December 31st. And we can also see that the data are actually sorted by date. And so the first thing we're going to do is to sort these data by the discharge in column B. So the way I'm going to do that is I can highlight all the data that I want to sort. And I want to highlight all the data, not just that column, but both columns A and B. And now go back to the top, and I am going to choose data on the ribbon and then sort. And a couple things I want to do here. I want to make sure this my list has headers is not checked. And then I want to sort this by column B, that's the discharge. And I want to go from largest to smallest. Hit OK. And there we go. So that's all I've done. I've now rearranged the data so that it's not sorted by date, with January 1st being the first, but it's sorted by discharge. If we can see that during this year, 2023, the largest discharge was over 12,000 cubic feet per second, and going down the bottom, the smallest was only about 3. So there was an enormous variation in the discharge during this year. So to perform the analysis, I'm first going to rank these, and the rank variable is called M. So M is the rank. And the largest discharge day I've seen is rank number 1, and the second largest is number 2, and the third largest is number 3. And instead of just going down and typing 1, 2, 3, I can use this sort of cool function in Excel. I can put in the first 3, and then I'm going to select those, go to the lower right hand corner. See, my cursor here is like a big white plus, and when I get to that corner, it's going to turn to a small black plus sign. That means it's ready to go, and now I can just drag this down to the bottom, and what I'm doing is just extending this sequence 1, 2, 3 all the way down to the bottom here. And I'm going to have to get me down to the bottom here. Where is it? It's going kind of slowly here. There it goes. Okay, there we go. Now, a couple things to check. Notice that the smallest discharge day was 365 and the first was 1, and this is something to check. So I actually do have 365 days of data. If I were missing a day, this number would only be 364. So make sure that we actually have a full year's worth of data. And then I'm going to go to the top again, and we're almost there. So now the probability is going to be defined as, remember, the probability is defined as the rank divided by the total number of observations plus 1. So I'm going to enter in here the equation equals C4. That is the rank found for that discharge in column C. So C4 is the rank of that discharge, and I'm going to divide that by the number of observations plus 1. Remember, I just checked, there were 365 observations, so this number is 366. And there it is. That's the probability. In other words, there's an extremely low probability that we're going to see a discharge equal to or exceeding 12,400 cubic feet per second. In fact, it only happened once in that year. And now we're going to copy this formula down just the same way we did before. We're going to go to the lower right-hand corner, turn it into a little small black plus sign, and then drag this down to the bottom of my, there's lots of different ways to do this. This is probably the easiest way, to the bottom of my data set. There we go. And now I have copied that formula, and just see that it makes sense. So the very smallest discharge was equal to or exceeded 99.7% of the time, right? It's nearly all the time. Okay. So there we go. Now, at this point, we want to create the graph. And to do that, actually, it's easier to do this little trick here. The reason being that it's sort of hard to select columns to graph that aren't next to each other in Excel. So what I'm going to do is I'm going to copy this column B. I'm going to click on the B, and then I'm going to copy it, and I'm going to copy it into column E. And I'm going to paste special just to make sure that I'm pasting the values. Okay, so it's exactly the same thing. So column B and E are exactly the same thing. Now the reason I did that is now I can select data that include the consecutive data in consecutive columns D and E. I'm going to select all these data and plot them. Whenever I graph things, the first column by default will be the x-axis, and that's what I want. I want probability on the x-axis, and the second column by default will be the y-axis, and that's exactly what I want. So I'm going to select all this data, these data here. Whoops. I'm going to go down and select, there it is. Go back to the top here now. And now I want to insert, where'd it go? Insert a graph. And the graph I want to pick is actually called a scatter graph. Let's see if I can just scatter plots. And these are all the different types of scatter plots. I'm going to actually pick this one here in the middle that just has a smooth line through our data points. We're not actually going to show the data points like they would here. That'll get too cluttered. Just a smooth line through the data points. And there is my graph. Now, let me move over here now so we can put it in a place where I can see it. Okay, there it is. Beautiful. Okay. Now it may look, we have to clean it up a little bit. It's a little bit hard to read. So first of all, we can give it a title. Let's say, what was this river again called? This was the White River. That's not how you spell Fayetteville. Fayetteville, Arkansas. Oh, Arkansas is AR, right? Okay, and a couple things. So now what I'm going to do to clean it up, one of the main things I'm going to do is I'm going to change, notice how this y-axis, the data are just scrunched up because there's such huge variation. So I'm going to change, this is a perfect time to use a logarithmic scale. So I'm going to change this y-axis to logarithmic, and you'll see how much it makes it easier to read the data. So I'm going to click on the axis numbers here, and then I'm going to right click and say format axis, and these are my choices here. I'm going to decide to, let's see, I'm going to use a logarithmic axis, and you can see how much easier it is to see that now. The other thing I'm going to do here, let's see, I could actually, if for example I had no data less than 10 cubic feet per second, I could decide to start my x-axis at, y-axis at 10, but I have data that range through, all the way over 10,000 and over 1. So I need to include all of these different values along the y-axis. I'm going to click on the x-axis now and change the maximum value to 1. Remember, probabilities aren't defined above 1. And also, to make it easier to read, I'm going to change the major increment to 0.1, and let's change the minor increment to 0.01. Now I can't see that yet. I'll have to, so I'm done with that now. Okay, whoops. Where'd it go? Okay, there we go. So now what I'm going to do is right click on the on the x-axis and choose to add minor grid lines, and I'll do the same on the y-axis. Add minor grid lines. There we go. So that is a beautiful flow duration curve for the White River near Fayetteville, Arkansas. A couple things I could do here. I could actually make this line a little maybe thinner. I think the weight is a little high, so let's just go to 1. That makes it a little easier to read the details there. I could label my axes here. The way I do that is I click on my chart, and then I go to Format, and I go to Chart Design, and then add a chart element here on the left. Add a chart element. Axis titles, the primary one. This is probability. And then I'm going to add a chart element, the vertical one, and this is, remember, this is really important, this is discharge Q in CFS, cubic feet per second. And there we go. And now I have my beautiful flow duration curve. Now, I'm asked a couple questions, and these are going to be really easy to answer. So first one is, what is the median discharge of the river? What was the median discharge of this river during the period of observation, which was 2023? And a couple ways I could do this. One would be just to look on the graph itself and find the discharge at 50%. 50% of the time it was greater than this discharge, 50% of the time was less. And if I zoom in here, I can say that in this case it's very, very close to 100 cubic feet per second. Now there's actually an easier way to do this when we actually have so much data, so many data points here. And that is simply, these are my QFS. I can just simply go down and look for the probability. These are probabilities that this discharge in column E equals or exceeds the value of probability in column D. So I can just go down and look for something that's at 50%, and I think I'm going to be able to find something pretty close. And I'll get an exact number here. There, it's actually right there. So there it is. It's 102. Remember, I guesstimated at 100. Well, it's actually 102. I'm just going to highlight that. So the median discharge is 102 cubic feet per second. Next question is, what is the discharge that is going to be exceeded 90% of the time? And once again, I could go read this off the graph here. 90% of the time, well, looks like it's about, let's see, that is 10, right? So 90% of the time is about 8, I'm guessing. It looks about 8, oops. So let's find our way back here and go down and see 90% of the time. Well, now we'll just sort of look for the value of 90% in column D. Let's see, 90% occurs right about here, right? So somewhere in here, that is my 8.5, what did I say? 8.5 cubic feet per second would be the discharge that's exceeded 90% of the time. And finally, I'm going to try to find the discharge that's exceeded only 5% of the time. This is going to be a much larger discharge. So these are going to be the big flows on the river. And once again, we can use the technique. We can go either look right on here at 5. Okay, 5 is sort of going to be in the middle here. So it looks like it's going to be over 1,000, right? Or I can just go down until I find 5%. Oops, 0.05 is what I'm looking for, and that is probably right about there, right? So this would be the discharge 1,690 would be the discharge that is exceeded, or that was exceeded in 2023, 5% of the time. And there you go. So there is the way we can use Excel to create a flow duration curve. It's a lot easier than doing it by hand, and it's a lot more accurate than doing it by hand.